So today I'm really excited to present this new project called CodeClash, and the title Benchmarking Goal-Oriented Software Engineering. I am I'll provide a little bit of context before kind of diving into the specifics of the project. I would say basically for background, I've been working in kind of the code evaluation, coding agent space for the past couple years. So some of my prior works have included things like SWE-bench and SWE-agent, SWE-smith, stuff like that. But kind of taking a step back and just kind of revisiting what code evaluation has looked like. The pretext is these days, code and language models seems to be a pretty hot topic. Like people care about code, people care about language models that can code effectively, and we have a suite of benchmarks for evaluating language models on code. And so I would say that probably one of the more prominent works in the field was released by OpenAI about like in 2021, 2022, and that was the human eval data set, which is kind of a funny name for like a coding data set, but that's what they went with. But the idea there was like, we wanted to evaluate like GPT-2, GPT-3 on these questions of like, here's a method header, here's a doc string, generate the function completion. And over the years, we really adopted that paradigm and we took it from like LeetCode easy problems to like LeetCode hard, and then to things where they were like Olympiad level, function completions. But that was kind of like one vein of code completion, of code evaluation, which is completing a function. Now, a lot of these things were fairly self-contained. You were just dealing with Python, you were just dealing with this specific one function with specific input-output pairs. And so another big sort of gear shift in code evaluation was SWE-bench, which was released like 2 years ago at this point. And the idea there was like, let's take a step more towards reality, more towards larger software systems. We're not just worried about small functions anymore. We give language models a code base. We give them an issue, like a GitHub issue, and we ask it to actually like through some methodology, generate a PR, generate a diff, or like interact with the code base such that the issue is resolved. And so now, it's across the headlines and the news of just like cool systems like Cursor or OpenAI Codex or Claude Code, Gemini CLI. Every frontier lab has their own product now. Like Google just announced anti-gravity. And so code is very much on the brain for everybody like across the language modeling community. The one question that I think is kind of worth asking is, wow, language models are like exceptionally good. Like they've pretty much fully saturated human eval at this point, and they're getting really, really good at SWE-bench. So they're getting to like 70, 80% performance on SWE-bench verified. And so that begs a question potentially of like, what does the future of code evaluation look like? So I think to kind of examine that a little bit more closely, one of the premises of this talk and this work is this criticism of what we refer to as task-oriented code evaluations. And so what do we actually mean by a task? I think the way we frame it is language models are effectively being evaluated kind of like entry-level software engineers. So if you think about just kind of the general paradigm of things, we ask it basically, here's a function, or here's a bug that you need to fix, or here's like a feature that you need to implement, go do it. And then we use a bunch of unit tests to evaluate, how effectively or how correctly that fix was carried out. But what's missing from that whole paradigm is like why we even code, like the underlying motivation in the first place, right? Like for an entry-level developer, you're not really asked to like think about how this fix propagates or affects the rest of the software system. Or, when people take this overall goal of like improve user retention or, reduce costs or something like that. There's a lot of this like goal decomposition into tasks that's occurring that is just completely not reflected when you get to kind of like these leaf nodes of implementation steps that you need to do. So taking a very close look, you can just see as kind of a quick example, SWE-bench verified one of the task instances. The model is being told, hey, there's like a function. I want to be able to override this particular attribute of this function, and I can't do that because that argument or that parameter is not being exposed. Here's a code snippet that allows you to reproduce this issue. And then in this case, the definition of the expected behavior is pretty straightforward. Like, oh, like I just want to be able to override this. And I think this is like a pretty typical GitHub issue pattern in terms of like what elements it captures, like description, what is the actual problem? Sometimes you have a code snippet for reproduction or some stack trace that reflects this behavior in a very empirical way. And then some definition of like, actually what I want to do is this. But what's completely missing from here again is like, why does this even matter? Like, why do we even want to override this function in the first place? Like, how does this kind of like, is this part of like some big version change? Like, basically like, where do all of these tasks even come from? And I would say that's something where if you simply just scale up the existing evaluation paradigms, I would argue that you wouldn't ever capture these elements. And so I think like to kind of contrast and capture what's really missing, we take a step back and just think like, why do we even code in the first place? And obviously we don't just wake up and start knocking out random GitHub issues without, any sort of like larger goal in mind. Like we're very much driven by these high level objectives. Like, Alex wants to publish a research paper related to journalism. And so all of those tasks of like processing the data, doing transformations, writing a website that like people go to and then like look at these things, like you're not going to see those in tasks, but Alex knows that. And it's that goal that's driving all of that underlying like software development work. And so I think this is something very compelling to bring into the fold, where using the prior analogy, system design architects and like senior software engineers, like you're not just considering the task, you're considering like, I want to reach this general objective. How am I going to get there via, how am I going to get there via software? And of course it looks like tasks, but there's this whole layer of like decomposing goals and prioritization, experimenting with solutions, failing, iterating on real world feedback that you would just be completely missing from the current evaluation paradigm. So hopefully I've sold you on this, but I think that's kind of the premise of all of this. So this seems like pretty high and mighty so far. And so to kind of ground things back in the real world a little bit more, now the question becomes like, okay, if we're sold on this idea that goals are kind of more, compelling than tasks, then what is like an initial step that we can take towards evaluating coding agents as goal-oriented developers rather than task-oriented developers? So one concrete precedent that I think we've seen in the field so far is like competition as a way to kind of like evaluate models against one another. And so we've seen things like LM Arena, or for example, like Design Arena these days, where you have kind of like humans voting between, which is a better completion or which website better satisfies their request with something like Design Arena. And so I think a good proxy for whether language models achieve a goal is to kind of make them compete with one another. And so the idea here in terms of how to kind of merge, voting and competition oriented benchmarks with coding benchmarks is to find these kind of settings where code is actually competing. So what this means is like you have a code base. To evaluate its quality, you're not doing unit tests, you're not doing like integration tests. What you're doing is actually executing the code base, sometimes against one another, and you're actually like rating their performance. So I think the first jump towards that is if you look at kind of performance-oriented benchmarks, like, AlgoTune or like kernel bench, things where you're like asking the model to speed up the code base. So in that sense, there's no sort of like right answer. You're just asking for it to kind of achieve this high level goal. I don't know how you're going to get there, but just optimize the code base such that it runs faster. Now, obviously that's kind of narrow. And so what we're trying to do with this work is kind of demonstrate that, oh, there's like a wider range of benchmarks and arenas and real world software systems that you could fit into this paradigm. So anyway, basically our project is CodeClash. So kind of with all of that context in mind, the evaluation paradigm that we introduce is this idea where you have two or more language models and they essentially maintain their code base across the span of a multi-round tournament. And what that means is basically they maintain their own code bases. They can evolve their code bases however much they'd like and however much they want. It's totally sort of self-determined in that way. But basically the objective they're told is like, hey, you're going to compete in an arena. Briefly, this is what the arena is about. Like, for example, in this case, the simulation is showing a programming game called Halite. And so there, the idea is like you want to write a code base or a bot that's really good about performing resource acquisition or like conquering sort of an opponent. And so, you ask the model, hey, this is generally the game. Here's a starter code base with anything that you should need. I'm going to ask you to basically write the best bot that accomplishes sort of the goal in this arena. And I want you to outcompete your components on it. So specifically, just to kind of dive into how CodeClash actually works, the idea again is like two or more language models in a multi-round tournament. And what this means is like per round, there's two phases. So per round, all of the models go through an edit phase. So what that means is like each language model has their code base and they get to interact with that code base and sort of update it and edit it however, in whatever way they'd like. So if that definition seemed a little bit fuzzy, this is very much just picking up on a lot of the agent scaffolding work that has come out around coding agents in the past couple of months. Things like SWE-agent, OpenHands, like nowadays like Claude Code, Gemini CLI. Basically, given a model and a scaffold and a code base, you let the model kind of update the code base however it wants to. After a fixed number of turns, the edit phase ends, and then you enter the competition phase. And this is where, within the context of a specific arena, the code bases are run against each other. So to kind of make the definition of a code arena a little bit more concrete, what we found in practice is that things like programming games are sort of very much hit the nail on the head in terms of what we're going for here. So you have games like, BattleSnake, Core War, Halite, Poker, RoboCode, Robot Rumble. The idea here is that they're all programming games. They'll take in like multiple code bases or like multiple bots, and then these bots will actually compete against each other. So right here, you're kind of seeing BattleSnake, which if people have played the Snake game from a while ago, the idea there is like in your solo player version, you have a snake and it's kind of eating pellets and it's going to try to avoid hitting itself or hitting a wall. And you see how long that snake can grow. BattleSnake is very much just that, except you're not playing the game directly. Like you write, a code as controller, like a literal Python script or a Python code base that controls and operates as a snake. And you're going to be playing against other people's snakes or other people's code, where, if your snakes collide head on, then the longer snake is the one that lives, or if a snake hits another snake's body, like you can try to wrap around an opponent, stuff like that. And so there's a lot more. BattleSnake on the left, there's like RoboCode, which is this kind of like tank control game in the middle, and then Robot Rumble on the right, which is this sort of like swarm control game. We include 3 others, so like Poker is probably pretty intuitive. Core War is this pretty fun, like it's this game written in like 1984, where the idea is it's like you write essentially like in a very assembly like set of instructions, and you run that piece of assembly code, and they're kind of competing in sort of this memory core. So they're kind of jumping around registers like a CPU register, and they're kind of like leaving bombs. I guess there's a lot of like game specific terminology, but hopefully this is illustrating the idea that like, there's a lot of these programming games that exist out there. And so this ended up being sort of like the test bed that we use to do this V0 goal-oriented software engineering. So generally the definition for Arena is quite abstract as written on the bottom. In practice, we fold a lot of programming games in. To be very kind of transparent, I think this is probably the biggest part of CodeClash that could evolve in the future. I think it's also its current biggest weakness, which is that, they're programming games. There's a little bit of like a disconnect from reality. They're certainly writing code, but you could make the argument that programming games aren't super useful. But I think it's still super exciting because this is just V0. And if you think about it, there's a lot of like simulation logic or environments that exist for testing code in environments like cybersecurity or like financial markets, or there's even things like city planning or supply chain management, where you have these simulations for testing like business decision logic written as code and coded as programs. And so I think the future, or sort of the next iteration of CodeClash that could be interesting, is folding those kinds of more realistic arenas into this setting. But cool. Anyway, that's the definition, that's the setup, all of these things. Just to quickly visit, beyond sort of the arenas, why I think this setting is cool, kind of looking back at our initial set of motivations, something I like here is, you have a lot of diverse arenas. It's not sort of like SWE-bench where, with SWE-bench, like the task form, you have 500 task instances, but the format of the problem is essentially the same with variation in kind of the repository that you're targeting. Like here, the arenas are like drastically different from one another in terms of like, the things that your bot actually needs to do, the language that you carry things out in. When you're playing code, when CodeClash is running round to round, what happens is in round N, you get feedback from the competition in the form of logs from round N-1 and everything, previously. And so those logs look very different. You're going to need to like parse those logs. There's this challenge of like understanding logs effectively, using those logs to understand how to improve your bot, how to understand what the opponent is doing if you want to tailor like a specific countermeasure to what your opponent's code is doing. And so I think what becomes very prominent in this setting is this necessity of like self-determined improvement, true autonomy, as opposed to sort of like prescribed, here's a task that you need to solve, and here's this kind of general workflow that's probably going to work. Yeah. Okay, but getting more into the fun stuff. We have CodeClash, we have this nice task formulation, we've adapted 6 arenas into it, and now what we're going to do is actually see how well models stack up against each other. And so unlike before, again, we're not going to be doing unit tests or whatever. Like now we're going to make models compete, and we're going to see ELO, and we're going to see real ranking. So we evaluate 8 models that are supposed to be pretty good at coding according to SWE-bench scores. And then the scaffold, the agent scaffold that we use for facilitating interactions between a language model and its code base is this scaffold called mini SWE agent, which is a derivation of the original SWE agent paper with the unique caveat that it doesn't have tools. So the interactions with the code base are completely bash oriented. And the reason we do this is because, one, I think there's an increasing trend towards just letting language models write their own tools. And 2, I think there's some evidence that like adding tools, it like biases accidentally towards one model against the other model. And I think the compelling thing about writing its own tools very much is, in sync with this kind of self-determined, the model creates its own tools, decides what it wants to do kind of theme that CodeClash is going for. So we have the scaffolds, we have the models. In our main results leaderboard, we make the models compete one-on-one in each of the arenas. So you can imagine like 8 arenas, they play one-on-one, so that's where the 8 choose 2 comes from. They're going to compete across all 6 arenas, and then per model pair and arena, we're going to run 10 tournaments with 15 rounds each. So that's where we get this kind of final 25,200 number. And basically, every round has a winner, and every tournament decides like a winner or a champion based on who wins the majority of the rounds. So the idea is that we run 15 rounds. The model that wins 8 or more of those rounds is declared the winner of that tournament. And then based on the outcomes at the tournament level, then we compute elo. And so like we go into that more in the paper, but like it's pretty much just kind of what you would expect. Cool. So yeah, we have these numbers, and then now we can get into the more fun part with results. So we run across all 6 arenas, all 8 models. We see Claude Sonnet 4.5 comes out on top. Not super surprising by some measure, given all the publicity around how Claude is very good at code. But I think the main interesting thing that I personally like about this table is that if you look at the per arena elos, you'll see that Claude doesn't actually dominate across all 6 arenas. It dominates specifically on 3 out of 6. So it's incredibly good at Core War. It's pretty good at BattleSnake. I mean, there's like a 100 point elo gap between itself and the next best model, but it's not as good as something like, Halite or RoboCode. And funny enough, like for poker, you can imagine maybe there's like the Noam Brown touch when it comes to GPT-5 just being exceptionally good at this particular arena. But anyway, that's one thing. So I think like leaning back on that idea of like adding more arenas, I think it would be really cool to fold in new arenas, and you can really see like, okay, which models are good at cybersecurity, like which ones are good at deploying things in financial markets and in like ride sharing simulations and supply chain markets. And I think there's a lot of interesting observations that could come from that. But beyond just the win rates, when you look a little bit closer, so on the left side, we just see like head-on win rates between model pairs. You can see, for example, like Claude 4.5 wins very handily against the weaker models, but it's actually pretty neck and neck with GPT-5, which is kind of second place on the main ELO board. On the right side, what we're seeing is win rates per round. So we just marginalize across all arenas, and we kind of look specifically per round, like how often does it win that round. And what we see is like there are actually trend lines that emerge that suggest that, Claude Sonnet 4.5 somehow kind of has a steady growth in terms of round over round, like it wins the majority, a larger share of rounds later in a tournament as opposed to earlier, versus you see some models where they kind of like start off a little bit stronger, but like as the game proceeds, the win rate is not as high as it was before, like GPT-5. And so we have more analysis in the paper, but I think it starts to suggest this idea that different models have different levels of proficiency when it comes to evolving their code bases across a long horizon in response to like logs and kind of the dynamics of the game. And I think that's quite interesting. Cool. Another cool result is yes.
I think you might have one question from Alex.
Oh, no problem. Yeah.
Yeah, it's okay. I realized the answer. I was just reading the table in the wrong orientation. It's fine.
Oh, no worries. Okay, cool. Awesome. Yeah, no problem. Feel free to stop me whenever. Thanks, Alex. Yeah, cool.
I guess my brother over here has a question.
Oh, awesome. Hey, nice to meet you. Yeah.
This is amazing work. It's so interesting. I'm curious if you could give like a little intuition as to, why numbers aren't like super bimodal at 0 or 100, like why models don't always dominate. What are some of these cases where a weaker model can even win? Is it just like stochastic tries will just trip up one of those stronger models or something?
Oh, yeah, I think that's a great question. I think interestingly enough, even in like SWE-bench, when you do multiple rollouts on the task instance and you set temperature to 0, you actually still kind of see non-determinism in that setting where it's kind of, yeah, I mean, chalk it up to maybe like, instabilities in inference, or that like, models just because I think like CLI code base environments themselves have this kind of level of non-determinism, like simply adding or toggling like an argument to the find command will like change the way results look. And so I think basically this cascading effect of like slightly different actions with like slightly two like really different outputs will sort of cause discrepancies within even the span of like rolling out from like a single round. And then on top of that, you have like the multi-round component where even the arenas themselves. So a detail I kind of skipped over that is fairly important is that for a lot of these arenas in and of themselves, like there is non-determinism. Like when I run BattleSnake and the bots that they code in BattleSnake, you actually do want randomness because that's kind of like to your advantage, especially for something like poker, right? And so when you add that in, then the logs are going to reflect that like, oh, we ran 1,000 simulations of BattleSnake per round, and you're going to get like different distributions. So like the way we determine a round winner for BattleSnake is like run 1,000 games of BattleSnake, and then whoever wins the majority is the round winner. But like that's kind of coarse grained, because if you actually look at the logs, is it like I won 700 out of 1,000, or is it 800 out of 1,000, or is it 1,000 out of 1,000? Even then, like the logs could look quite different. Do I chalk up the losses or the wins? Is it to chance? Like, is it because like, oh, you know, I won 600 out of 400, but is that like a solid win, or is it like, oh, I just kind of got lucky? And so I think just all of those factors make the environment like super dynamic. And I think that's the non-determinism that makes me also feel like why for figure 3, these kinds of trend lines are actually kind of worth reading into. Because it's not just like, oh, it just kind of so happens that if you did the same 25K rounds that like you'd get different things. I do think it speaks to a model's ability to deal with non-determinism. But yeah, that's a good question. Sorry for rambling a bit. Yeah. Cool. Awesome. Okay. Yeah, I will try to, okay, I'll keep going. I'll try to wrap up within the next 10 minutes. Shouldn't be too hard. But a result I kind of like, and I think if you're looking for something fun and you just, you know, have like 2-3 minutes of free time, we have a blog on like the actual CodeClash.ai website. But one thing I like here is for Robot Rumble, they have an online leaderboard, and that online leaderboard features like submissions that people have written, and some of them are open source. So what we did to just quantify the gap between like models and like the best human written bot is we found that open source bot, we like downloaded it, and we said, okay, Claude 4.5 Sonnet, I'm going to give you 15 rounds. You're going to start with like a very sort of like suboptimal bot. It's by no means terrible, but it's not the best bot. You have 15 rounds. You're going to compete against this static human submission. So Claude doesn't get to see the code, but it just, you know, it's not competing against an evolving opponent. It's just against this kind of fixed human submission that happens to be very, very good. And let's just kind of see what happens. And so we ran 10 tournaments of 15 rounds, same as before. You know, all of those parameters, blah, blah, blah. And it goes up against this bot that is, you know, named GigaChad. That is not a name I prescribed. It's just how the way it was. And the funny thing is Claude 4.5 loses all 10 rounds, loses all 15 rounds for every single one of those tournaments. And if you take into account the simulations, kind of like we mentioned before, like 1,000 simulations for BattleSnake, it's 250 for Robot Rumble just because of compute reasons, because that game is a little bit more intense to run. And if you multiply like 250 with 10 with 15 to get the number of simulations, Claude's bot wins exactly 0. So why is this significant? One, I think obviously there's like a human AI gap, but I think these days you see a lot of claims about like, oh, I ran Claude for like 4 or 5 hours on a task and it came back and it did something really excellent. And it's really hard to like verify those claims because there's just not really an empirical setting where you can kind of like show this or capture this. So I think CodeClash does this to some extent in that I gave Claude basically like the best open source model, and essentially what I asked it, or sorry, the best open source bot. And I just asked it to do something simple, write a bot that is better than the open source bot. And so with all the hype around kind of like IOI and sort of a lot of these math things, you could have like a reasonable hypothesis that like, yeah, this is just a programming game. This should be nothing to GPT-5 or Claude. And so I think just like the stark contrast that like this was 15 rounds. We did one tournament where we ran it for 50 rounds and just like it didn't make a dent into the human solution. And so I think like if you look at the logs, it becomes very apparent that like models struggle with iterating on logs and kind of grounding their decisions in concrete, insightful feedback. But I think this is just, something exciting, but cool. Other than that, models interact with code bases very differently. This is more kind of like CodeClash giving a lens into the aesthetics and style of a model as like a long-running developer. So, we give them 30 steps per round, but they consume a very different number of steps per round. Like, Claude will use like 25 out of 30. GPT-5 Mini or like O3, they're a little bit more conservative. They'll only use like 15 out of 30 steps. I honestly don't have a good explanation for why, but that, there are differences there that seem to emerge. They edit different numbers of files. The number of lines they change across all those files per round are very, very different. Claude and all the Claude models are notorious note takers and notorious like script creators. We'll see that in an upcoming slide. O3 is kind of like a monk. It'll just kind of like only touch the bot file and it won't do analysis scripts. It won't sort of like have a lot of performative stuff. You could imagine like maybe what we want at the end of the day is actually something a little bit in between where I have a model work on my code base. It's producing like good analysis files, good nodes as artifacts, and it's doing it in an organized way while also evolving my code base. But yeah, another noteworthy thing, model solutions are actually becoming more and more different. So one sort of like one question that's reasonable is like, well, is it just doing the same thing every tournament? Like, is it just arriving upon the same solution, agnostic of opponent? And so what we did is for BattleSnake, we just looked specifically at the core logic related to the bot, which is just a single main.py file. And we just did like a straight up difflib computation between them. And what you can see is that like by the 15th round, the solutions are actually getting quite different. And even though the logic is kind of faulty, when you actually inspect the code that they've written at that point, you do see a mix of attempts at absolute improvement, but also like, oh, based on round 7, it looks like my opponent in BattleSnake is implementing this kind of flood fill behavior. And so I'm going to try to like account for that by doing something in response. Yeah. Cool. And another thing, I think another big theme of this paper is just how good are models actually at iterating on feedback, whether that feedback is I lost a round or actually sort of writing analysis scripts to understand the logs. And our conclusion is just that, like, generally speaking, this is something that models just struggle quite a bit with. So the chart on the left is this nice, simple empirical number to just say like how frequently does a model win the next round when it's lost the past n rounds. And so you can see like the more rounds it loses, the more subject it is to continue that losing streak essentially. And so like yes, yeah, and models kind of like struggle to adapt.
I have a question.
Yeah.
For the models that struggle to adapt, have you tried like any reinforcement learning approaches to see if they will take in the negative feedback and then basically learn that way?
I'd be really excited. I'd be really excited to try that. Did not have the compute budget, but I think this is like, I mean, I would almost venture to say, I think it'd be really fun to just take like a decently good 32B like coding agent model, like maybe code world models from Meta or any of like the good models that have come out. And I think that would be really cool to just see like, RL on some pretty basic signal, like, oh, this trajectory, versus this one led to a win. So I haven't tried it, but I think that would be super exciting. Yeah.
Well, that sounds cool. If you do it, let me know.
Sounds good. Yeah, no, for sure. Haven't kicked it off yet, but yeah, no, that I'm 100% agree with you. That'd be a cool follow-up. Yeah. And then this is my favorite one. If any of you guys want to, need a tweet and you just want to put something out there, happy to share this with you. But On the right-hand side, this is Claude Sonnet 4.5's code base after 15 rounds of BattleSnake. So you see it's added 52 new files. It's out of the 52, only the main.py is a modified file. So there's 51 new files with nearly 6,000 new lines of code and only 14 lines deleted. And if you actually look at the files, there's round 14 summary, round 3 summary, round 5 summary, and round 9 summary. But for some reason, there's no round 2 summary or round 7 summary. If you look at the analysis scripts, you might find some nuggets there. Analyze round 13, analyze round 13 v2, analyze round 13 v3, and you have no clue like what the differences are there. If you look at the notes, it'll kind of like say it's not very well documented. If you look across all of the analysis scripts, you'll see that there's high amounts of redundancy. Like it's essentially like redoing the same analysis code, but just pointing it at like very specific paths that point to like very specific log files. I mean, I would imagine like hopefully this is not going too far or insulting in any way in case people do code like this. But I would say that this is probably not great in terms of code smell, code organization. Probably wouldn't be accepted as a PR if you submitted this at a company, So I think something about just like organized code bases being important, not only because like maybe it's necessarily important to models that can actually evolve their code effectively, but also that like if you want these kinds of agents, these background agents to be useful for humans, then you probably want the code bases they produce to be built upon and to be organized and to be like easily something that we could pick up where they left off. So this is, a fun slide just to kind of quantify. Model code bases are quite messy, I would say. Yeah. And then last but not least, we did some sort of like annotations. I won't dive too deep because I think this is a little bit dense. But basically we came up with a bunch of like annotation tasks for a language model. As a language model, hey, like here's like a trajectory, tell me like whether this trajectory's core edit, like main changes to the logic behind the bot, are they grounded in like logs or are they grounded in some sort of analysis? And that's the left-hand chart. On the right-hand chart, in the middle chart, we ask it, okay, how good of a quality was that analysis? Like, yes, it's grounded in some argument, but how sound is that argument, And so you get some rates there. And then on the right-hand side, what we're asking is, okay, after a model made a change to the bot logic, does it actually run tests or write scripts or do some sort of testing to validate the effectiveness of that change? So those are the overall 3 questions. You can see different rates for different models. I won't get into it too much, but I think the big takeaway to me here is that there is attempts to kind of ground in logs. So I think on the left-hand side, it's nice to see that, for example, the Claude models are very like, okay, well, based on this, I should be doing this. I think the part that is quite questionable is the part in the middle where oftentimes like you'll see it pick up on logs, but the conclusion that it's drawing or the insight that it claims to draw from this source is like very questionable, and it'll sometimes it just might not be the right takeaway. And so yeah, I think there's honestly a lot more to do here in terms of like better at scale qualitative insights, but I think this is something we found cool. But yeah, that's pretty much like the main results. I think we have like the I'll just kind of show off the assets aside from the slide. So we have our website here at codeclash.ai, and so there's some basic things we wrote about the arenas. Well, we only have a couple like posts right now. This is the human versus AI experiment. We'll probably try to add a little bit more in the coming weeks. And we want to try to add more arenas too. And I think the part that I like a lot is if you're ever curious about what each of the games actually look like, just click on this trajectories button and it'll take you to this viewer site that we wrote. And then here's like one of those games. So for example, this is Claude 4 versus Claude 4.5. And I'm pretty sure this is BattleSnake, although I guess we should make that more apparent somewhere. You can kind of see on across 15 rounds. Their code bases in round zero, like round zero is just like a warm-up round. Like there's no changes made yet. And you can see like, okay, Claude 4 made a change where it starts to win the majority of the rounds. And there's like a fun sort of like back and forth that's going on where like, okay, somehow at the end of round two, Claude 4.5 made a pretty good change that gave it the lead in round three. And Cloud 4 kind of reclaims the lead. And if you want to kind of look at the trajectories, you can like click somewhere down here. You can expand the trajectory to see what's going on. Like this is the system prompt it receives at the beginning. I'll say like, this is Cloud 4. So, oh, I need to like look at the code base. Let me see what I did in the previous round. Cat the readme, it'll probably like, it's like looking at the bot in this case, so you'll kind of see that stuff there. So anyway, I think this basically just is like a fun way to view the data. If you're curious enough that you like want the data, I'm very happy to share it. We're probably gonna make it public at some point, but for now, just we haven't open sourced it yet. But anyway, I think there's a lot of cool follow-ups. Like one is certainly like beyond head-to-head. What if it's like three or more players? Like imagine running poker with 6 players. Like what does that look like? It's probably absolute chaos, but it'd be interesting to see the dynamics there. Just like different tournament setups. I think training is cool. I just haven't touched that part at all yet, but I think it would be cool to see, after everybody's kind of over-indexing on SWE-bench, like which models are the ones that actually have capabilities that go just beyond this kind of like, let me solve a GitHub issue, and can really start sort of making coding decisions for themselves. But yeah, anyway, thanks for being a good audience. Thanks for having me for this talk. I'm pretty excited about this work. I think I'm gonna try to focus on this going forward. So, if this seems interesting, I'm always open to chatting more. Yeah.
Hey, John,
Great.
I have a
A huge,
question for you.
sorry, Henry, can I? Yeah, huge thank you, by the way. And I guess I'll take a cue. So can you please raise your hands if you're interested in asking questions? And Henry, I guess you can go first.
Cool.
The question is, I see a bunch of tasks
Yes.
like BattleSnake, Core War, or whatever. So
Yes.
you guys designed the tasks for benchmark for testing each of the coding tool, right? And so, when you design such tasks, what is in your mind you want to cover? Like somebody swim very well, another guy can run very fast. The other guy do the lift very
Yeah,
fantastically, weight lift. So, what is in your mind? You are trying to balance, or you are just trying to target a certain capability of the tool?
for sure. We actually didn't hand create any of the arenas that are reflected here. So if you go here, all of these arenas are real programming games that have existed for anywhere between 10 to like 30 years.
Oh, okay.
So we didn't actually design any of this. When we
Okay.
incorporated it, basic things we took into account is like the programming languages that were being tested. So for example, Halite, it doesn't use Python. It's like 4 languages available. BattleSnake is just Python. We also just like from a game mechanics point of view, tried to kind of make it rich. So for example, we have a lot of like grid-oriented games represented for sure, but then that's why we added things like Core War or Poker or like RoboCode, where they're not so much grid-oriented. Yeah.
Oh, I see. I see. They have been existing for decades, for maybe evaluated code, right? I guess. So, but looks like to me they're all games. But in real situation of coding tasks, how how do you think such games will represent what is done, for daily, business or whatever coding tasks? If you do this well, does it mean you are doing the real, coding task? Uh,
Right. Right.
well, so.
Yeah, that is definitely a weakness of the paper and a bridge that I think could be closed. So I think I would make two responses to that point, which I think is a good point. One is that models are coding, and I think coding in and of itself, it's high utility. So I think compared to like arenas where you're just kind of like voting about completions, I do think the fact that in here they have to produce code as an artifact makes it very compelling. In terms of the arenas themselves, I agree. The whole set right now is coding games. Some unique things. Halite was actually created by the CEO of Cursor, along with another PhD student at Stanford. And Two Sigma actually used Halite for hiring purposes from 2016 to 2018 for new grads. And so I think obviously Halite doesn't translate to like a real world problem, but I think the utility of like if you do well on this, it sort of demonstrates that, you have proficiency in terms of evolving code and kind of design. I think that skill set is already captured. I also think it's possible to add real world arenas. So something I'm actively thinking about is, you'll see stuff like, so Abides is a very popular library in the financial markets world where people have done here research into how to do like back testing in multi-agent market systems. And so, oh, okay, that's a little disappointing. But basically, there's a lot of these like supply chain, cybersecurity, finance, like a lot of non-coding domains where they have simulations to test code. And so basically, I'm very excited about folding these kinds of works into CodeClash. Yeah.
Good, good, nice. Thank you so much. Yeah.
Yeah, no problem. Thanks. Thanks.
Yeah, thanks so much. Thanks so much, Henry. I had a quick question, and then just if I can ask quickly. I know we're running short on time, but especially with in settings where the action spaces are kind of finite, we can imagine local optima that conflict with maybe our goal of having these higher level goals. So like
Yeah.
a local optima could be like you just programmatically code like your entire policy, right?
Right.
Um,
Right. Yeah.
and maybe that will work to get you to score okay, but like what we're really getting at, what you're really asking in the beginning is like, how do we get this higher level task decomposition and behavior that's like, maybe thinking more theoretically or trying to get at a more ideal solution. So how do you balance that? Is there a way to regularize that?
Oh, interesting. Yeah, kind of the balance between reward hacking, or sorry, if I'm understanding that correctly. Yeah.
Sorry. Yeah, reward hacking, maybe deterministically developing responses to your
Oh, yes.
opponent and like just
Yeah.
having really, really long code that's like entirely deterministic. But
Yeah,
yeah, maybe
makes sense.
suboptimal.
Yeah, I think that's a great point. Yeah, I think maybe my interpretation of your argument, which I think is super well founded, is like poker is technically like Texas Hold'em head to head poker. Technically, it's already solved. Like there's like pluribus or something like that. And so basically, why not just like hard code that solution or just kind of write something where it's like, I don't account for the opponent. I just know it's a good solution. Let me just kind of like do that and then be done with it, which I think is a fair point. So I think there's two counters. I would say um, I would hope that basically CodeClash is trying to communicate at some point the objective should shift from simply writing good code to writing code that outcompetes intelligent competition. Basically, it evolves towards like, outcompeting good competition. I would say absolutely right now, it's very questionable whether models are even good at writing like suboptimal solutions. But I would say basically like in the long term of this benchmark, I would hope that like a lot of these games, they don't necessarily have sort of like a God solution. I think some of them do, but some of them I think you'll get to the point where like you have a solution that's very optimized for this, but then there's always a counter for it if you're either aware of the code base or if you can decipher. So, and then at the end of the day, a lot of solutions that are optimal or kind of finite in the one-on-one setting I think automatically become non-optimal simply when you introduce another player. So like for poker, like one-on-one poker is solved, but the moment you have three or four players, just the dynamic of like having multiple participants makes it important that it's not just about like writing a good bot, but that you are actually accounting for your opponents. So hopefully, I think that's something that, you know, ideally like CodeClash will point out, and then maybe will become more apparent as like an important thing to have in our evaluations. Yeah.
Thanks so much, John. Israel, I saw your hand up, but you put it down. So Ridul, do you want to ask a question?
Yeah, hi. So my question is like, do you have any sort of information on like how much the models updated the code whenever they kind of updated the code? So I wanted to know if like there's an like in the middle of the rounds, if some models kind of completely refactored the code base and like from that point onwards, model got better or model got worse. So is there any sort of information on that?
Like information on in round N, like the model looked at the logs, changed the code, and then the code got better.
Yeah, I mean to say like uh, how often is there like a complete refactor of code by the models, or is there like just subtle changes every time? And if
Yeah,
like the complete refactor, then like does it increase the performance a lot or decrease the performance a lot, or like was there some sort of phenomenon observed of that type?
yeah, for sure. The magnitude of the changes to the bot code, I would get smaller and more specific as the rounds get later on. Very rarely would you see a model kind of like dump their whole code base, like, you know, RMRF, like all their logic, and just kind of start from scratch at like round 10 or something like that, which I think is noteworthy, because like if it was us, if we were on a losing streak, that's actually something that we, but models don't do this like ever. Yeah. Yeah.
Awesome.